Hi and welcome to Thermo Products training video series on the ABC Setup Rule. As we learned in the ABC Setup Rule introduction video, there are three critical elements that determine furnace performance: airflow, balance, and combustion. In this training, we will break down the key principles of combustion and examine the three primary combustion conditions. We will also cover how to properly test and adjust combustion using industry-standard tools and procedures to ensure optimal performance and compliance with safety standards. By the end of this training, you will have a stronger understanding of how to identify proper combustion, diagnose common issues, and ensure the safe and efficient operation of both oil and gas furnaces. Let's begin by answering a simple but important question. What is combustion? Combustion is the process of burning a fuel, such as oil, propane, or natural gas, by combining it with oxygen to produce heat. In a furnace, this process must be carefully controlled to ensure the fuel burns efficiently, safely, and completely. When combustion is set up properly, it provides maximum heat output with minimal waste and low emissions. However, if the balance of fuel and air is off, it can lead to poor performance, increased fuel consumption, and potentially dangerous conditions, such as carbon monoxide production. That's why understanding combustion isn't just important. It's essential for anyone installing or servicing oil or gas heating equipment. Now that we understand what combustion is, let's take a closer look at the types of combustion conditions you can encounter in oil and gas furnaces. There are three basic conditions of combustion: complete combustion, incomplete combustion, and excess air combustion. Complete combustion occurs when the correct amount of fuel and oxygen are mixed and burned efficiently. When this happens, the system produces maximum heat output while generating primarily carbon dioxide and water vapor. This is the goal for every properly operating furnace and the benchmark for safe, efficient performance. Incomplete combustion occurs when there is not enough oxygen to fully burn the fuel. This leads to the production of carbon monoxide and soot, reducing efficiency and creating serious safety hazards. Excess air combustion occurs when more air than necessary is introduced into the combustion process. While this condition is safer than incomplete combustion, it reduces efficiency by carrying heat out through the chimney and lowering overall system performance. Now that we understand the three conditions of combustion, the next question becomes, how do we know when combustion is set up correctly? The answer is through proper combustion testing. In the field, we don't rely on visual observation alone. We use instruments to measure and verify performance. Key combustion measurements include carbon dioxide, CO2, oxygen, O2, carbon monoxide, CO, stack temperature, draft, and for oil furnaces, smoke. Each of these readings provides important information about how the furnace is operating. CO2 and O2 readings help us determine the air-to-fuel ratio and overall combustion efficiency. Carbon monoxide, CO, indicates safety and whether combustion is complete. Stack temperature helps identify how much heat is being transferred versus how much is being lost up the chimney. Draft ensures the proper movement of combustion gases through the heat exchanger and out through the venting system. Smoke testing, used in oil systems, indicates how cleanly the fuel is burning. Next is the fun part: learning how to read an efficiency chart for number 2 fuel oil using CO2, O2, and net stack temperature. Let's start with CO2 and O2, the most important indicators of combustion quality. CO2, or carbon dioxide, is a direct indicator of how effectively the fuel is being burned. In a properly adjusted system, higher CO2 readings generally mean better combustion efficiency. More of the fuel is being converted into usable heat. O2, or oxygen, tells us how much excess air is present in the combustion process. As O2 increases, more excess air is entering the system, which dilutes the combustion process and can reduce efficiency. As O2 decreases, we move closer to ideal combustion conditions. However, too little oxygen can quickly lead to incomplete combustion and the production of carbon monoxide. CO2 and O2 are mathematically related and are measured from the same flue gas sample. As one changes, the other moves in direct relation, reflecting the balance between fuel and air in the combustion process. Net stack temperature is the total stack temperature minus the room temperature. It helps us understand how effectively heat is being transferred into the home versus how much is being lost up the chimney. To fully understand this chart, Let's walk through an example. If your CO2 reading is 12.5%, your O2 reading would correspond to approximately 4%. If your net stack temperature is 350 degrees Fahrenheit, your combustion efficiency would be 85.1%. That concludes the ABC Setup Rule training series. You now have a structured way to diagnose performance, improve efficiency, and ensure safe, reliable operation. When these three elements are properly set up, the system doesn't just run, it performs at its highest potential. Thanks for following along. And remember, when you get the ABCs right, everything else follows.